Good morning, everyone. 안녕하십니까? So, my name is Mashhiro Yokota of Central Nippon Highway Engineering Tokyo Company, and I'm belonging to Facilities Engineering Department. Now, I'm responsible for the design section of Expressway facilities. First of all, I'm very pleased to meet everyone here again. Also, we would like to thank Professor Kwon, who planned this seminar. I'm honored to be able to speak at this seminar. Today, I'll briefly talk to you about the next generation vehicles and tunnel fire safety in Japan. Currently, the next generation vehicles such as hybrid vehicle, plug-in hybrid vehicle, electric vehicle, which are becoming widely used in Japan, need more development. So fire characteristics, fire characteristics have not been fully confirmed. Therefore, we collect the latest information and overview the adaptability of emergency facilities in tunnels. Here is the content of my presentation. First, So I will explain the first theme, characteristics of tunnel fire. As you know, if a fire accident occurs, accident occurs in a road tunnel due to it being a closed space, so environment deteriorated due to hot gas and smoke will cause a human impact. And secondary disaster to the following vehicles will cause a human and physical impact. Structural impact will occur due to thermal effect on the tunnel lining, and social impact will occur due to traffic closure in this section. As a result, such negative impact will occur. For this reason, early firefighting and evacuation are very important in this situation. Next, I'd like to explain to you about wind conditions and smoke behavior during fire. When there is no wind in tunnel, the stratification of smoke which spread from a fire source occurs, and then the smoke descends to the road surface as timing goes on. In addition, even though there is longitudinal wind speed as some 2 meters per second at tunnel, the smoke backlayering flow might occur at the upstream of fire. However, in this case, the smoke maintains stratification condition and this doesn't descend to the road surface. If wind speed increases further, the smoke backlayering flow will not occur, and then the smoke will spread over the downstream area of the tunnel. So some countermeasures have to be considered. Taking into account these characteristics, we hope that tunnel users fully understand these characteristics. If smoke spreads and starts to descend, smoke reduces the visibility for the evacuees, and psychological shock due to fire reduces their working speed. Evacuation is very much affected by the presence of irritating smoke. When concentration of smoke density exceeds 0.4, their working speed rapidly reduces. Evacuation condition is determined by the smoke density at the eye level of evacuees. We have to avoid the number of people who are trapped. In other words, those who fail to evacuate due to being enveloped by smoke. In the afternoon session, Mr. Shimizu will explain to you about the countermeasures to improve these cases. Next, as you know, I would like to explain to you about the second theme of emergency facilities installed in tunnels. So tunnels in Japan are classified into 5 grades, and the facilities are installed developing on the grade. This figure shows the layout of tunnel emergency facilities and equipment. Communication equipment can provide information to vehicles to prevent secondary disaster. Alarm equipment can provide information. Alarm equipment can provide information to vehicles to prevent secondary disaster. Fire extinguishing equipment can fight initial fire at the fire site. Evacuation guidance equipment can assist victims to evacuate. Evacuation passage can guide victims to safe area. Smoke exhaust equipment can exhaust smoke generated by fire and maintain safe environment for evacuation. And water spray systems can suppress fire and the thermal effect over tunnel structures. I will talk to you about the third theme. In this figure, I would like to explain to you about the overall condition of Japanese expressway tunnels. This graph shows the total length of expressway tunnels. Blue line shows the transition for the total length of tunnels in expressways operated by NEXCO. In 2012, the total length of all tunnels reached 1,645 kilometers. Red line shows the total number of fire accidents in tunnels. By 2012, 354 fire accidents had occurred. This graph shows the statistics of the number of tunnel fire accidents in Japanese expressways. For 23 years from 1989 to 2011, 283 fire accidents occurred in expressway tunnels. 12.3 accidents on average have occurred every year. That means roughly 1 accident has occurred every month. Next, I'd like to explain to you about the statistical data of tunnel fire accidents on Japanese expressways. About 70% of the tunnel fire accidents occur due to vehicle mechanical failure. And the remaining 30% occur due to traffic accidents, such as own accident and multiple vehicle accidents. The percentage between these two is almost same. On the other hand, the types of vehicles cause fire accidents are passenger vehicles, fleet vehicles, and the other type of vehicles. So the percentage of passenger vehicle and fleet vehicles are around 45% respectively. That means those vehicles account for 90% of the total. The remaining 10% are the other type of vehicles, such as buses and motorcycles. We can move on the fourth theme about the spread of next generation vehicles and their fire characteristics. As you already know, next generation vehicles have become widely used as shown in this graph. The vehicle type which widely used in Japan are hybrid vehicles and plug-in hybrid vehicles, which account for 5% of total number of vehicles, and electric vehicles, which account for 0.05%. Compared with vehicles powered by fossil fuel, this percentage is not high. However, we estimate that fuel cell electric vehicle powered by hydrogen will become widely used in urban areas ahead of the Tokyo Olympic Games in 2020. This graph shows the heat release rate by passenger type electric vehicle. This experiment reveals that the heat release rate by this electric vehicle has risen twice. The reason of the second rise of heat release rate was due to the blowout of flammable gas from battery pack. And this graph shows the comparison of heat release rate between electric vehicles and gasoline vehicles. So each maximum heat release rate is almost the same, but the change state in heat release rate are different. While gasoline vehicles reach a peak in a short amount of time, electric vehicles reach a peak after 40 minutes. Therefore, more attention has to be paid when distinguishing the fire. So this table shows the result of the components of substance discharged from the penetration test on lithium-ion batteries. Various substances were detected, such as carbon monoxide and flammable methane, which are harmful to humans. However, these discharged substances differ by manufacturer, so we haven't grasped what kind of chemical compounds are actually generated. As I explained before, discharged substances will also change depending on the state of battery charge in vehicles. Current electric vehicles in Japan offer about 200 kilometers of driving range on full charge. To expand the range, higher capacity batteries are being developed. So the fire characteristics are still unknown. Now, let us take a look at the overview on how fuel cell electric vehicles powered by hydrogen will become widely used in the future. This graph shows the predicted number of fuel cell electric vehicles in the future. When this graph was conducted as presented, it still has not been decided the Olympic Games will be held in Tokyo. If we predict the number of the vehicles in 2020, it will be up to 600,000 vehicles. The battery technology of electric vehicles has advanced, and potential fire characteristics of these vehicles have emerged from the experiment, and still we only have limited information data about them. But basically, the characteristics are almost the same as those of the gasoline vehicles. However, when it comes to gaseous fuel, especially hydrogen, has smaller molecules and carries the potential risk explosion. These vehicles, including the safety measures, have to be fully understood. We summarized current tunnel emergency facilities, which correspond with these next generation vehicles. For fire detecting function differ by fossil fuel, and hydrogen fuel, and lithium-ion battery. For fire extinguishing and suppression, ABC fire extinguishers such as water hydrant and water spray system are used, taking into account water usage and the impact. For exhaustion of smoke, toxic gas, flammable gas, ventilation systems are used to control concentration, also following our future tasks. For state of battery charge and the combustion properties, firefighting measures have to be taken. For combustion properties, including emission materials, the plan of firefighting and smoke exhaustion have to be made. For vehicle structure, including battery position and high voltage power supply route, appropriate firefighting and rescue activities have to be taken. For your information, when you purchase a new generation vehicle, you can get a rescue guidebook. However, road administrators and firefighters who handle a large number of accidents have to immediately recognize the type of vehicles involved in accident and take appropriate action. Otherwise, not only secondary disaster will occur, but their lives will also be in danger. Therefore, rescue guidebooks reflecting all types of vehicles currently being published have been edited throughout the world, especially in the United States. Web-based learning for rescue personnel has been carried out by NFPA as well. These are newest example of the fuel cell vehicles in United States. So main vehicle cell. So we summarize the future tasks. Next generation vehicles are becoming widely used. We have to work on the following. So effective risk management can be achieved by sharing the risk information. This is the end of my presentation. Thank you.